Good afternoon and welcome to the AOI breakout session for the Earth Archive LiDAR sampling for Ecuador. My name is Jim Zeidler and I am an emeritus research scientist at Colorado State University, collaborating with the Earth Archive project as regional coordinator for Ecuador, where I have been conducting archaeological research over several decades now, primarily on the coastal lowlands. I want to quickly cover three topics in this brief introduction. The first is the nature of our Earth Archive approach when we move into a given country to do this LiDAR scanning, and I'm going to talk specifically about Ecuador. Secondly, I want to do a brief presentation with a map of Ecuador, showing the 5 areas of interest that we have selected for our future LiDAR scanning on a very broad scale. And finally, I want to close with a brief introduction to our lineup of presentations for this session. The proposed Earth Archive LiDAR scanning process is multifaceted, and I just want to cover 6 basic aspects of it. And I'll let you in the audience read this, but while I just hit the underlined things here and talk briefly about them. First of all, it's crowdsourced. The funding is crowdsourced, which means it is free to the host nation, and this will be our main means of underwriting the LiDAR scanning and capacity building for data analysis. Secondly, we will be providing state-of-the-art LiDAR scanning of pre-selected areas of interest, or AOIs, at 25 centimeter resolution or fidelity, and our emphasis will obviously be on the Amazonian lowlands, although we hope to also cover some areas of the Manabí coastal lowlands. Thirdly, we intend to maintain a close collaboration between Earth Archive and the Ecuadorian government and other agencies at a national level through IMOUs, or International Memoranda of Understanding, with various universities and partnerships with pertinent government agencies and non-governmental organizations. Fourth, storage of resulting LiDAR as digital twins. We will provide a complete set of LiDAR imagery to the Ecuadorian government, probably through the Instituto Geográfico Militar, and another set for Colorado State University. Fifth, we are intending this to be open source data sharing, but that has to be developed in consultation, close consultation with a diverse national committee, including Earth Archive personnel and various non-governmental organizations, university specialists, and government personnel to make sure that everybody is in agreement over who gets access to sometimes sensitive data. Finally, we hope to incorporate into this process a means for capacity building and technical training for data analysis of the eventual LiDAR scans. And it is our hope that this data will provide, maybe up to 10 years of future research, both in Ecuadorian, as much in Ecuadorian archaeology as in areas such as tropical ecology, biodiversity, geomorphology, and geology. Next, here is a map that briefly shows the 5 areas of interest that we have selected. And for the Amazonian lowlands, this was decided upon in close consultation with the Instituto Nacional de Patrimonio Cultural, specifically with Fernando Mejia, who is part of this symposium. Going north to south, we have 5 relatively large areas to cover. That is basically a complete coverage of the Amazonian lowlands, northern, central, and southern. And you can see on the table on the right the square kilometers that that this comprises. And then in addition to that, we also hope to cover heavily forested areas of Manabí province, specifically in northern Manabí. This is an area where I've been working for a number of years in the Hama Valley. But basically, we're going from south of Bahia de Caracas all the way up to the northern border with Esmeraldas of Manabí province, and considerably far inland, not in the entire Manabí province, northern Manabí province. And then finally, a smaller area of interest in southern Manabí, where we already have some LiDAR research, which will be discussed in our symposium, but we hope to be able to cover that same area around Cerro Jaboncillo for comparative purposes and methodological purposes. So we can see here that the total area to be covered in our proposed scanning is just over 150,000 square kilometers. And finally, just a quick overview of our session. You can see it's broken into 4 parts. This is the first paper of the introductory papers. We plan to have Fernando Mejia representing the perspective of the Instituto Nacional de Patrimonio Cultural on LiDAR research. He's going to summarize LiDAR research that has been done in various parts of the country, some of which is covered in the other papers in this session. Next, we have 4 excellent papers covering the Ecuadorian Amazon, all by well-known archaeologists that have been working in these areas for a number of years. Francisco Valdez, we're moving south to north in this case. Francisco Valdez, followed by Estanislao Pazmiño in the Upano Valley, Catherine Lara for the Cois Valley, Ferran Cabrero for the Pastaza Basin. And then in coastal Manabí, we've got 3 papers led off by Juan Gijon, who will present some of this earlier LiDAR research that's been revolutionizing the archaeology of the Cerro Jaboncillo Hojas area, followed by Florencio Delgado, who will talk about the Coaque Valley in northern Manabí, to be followed by a joint paper by myself and my colleague Corey Herman, covering my research, long-term research in the Hama Valley, and some new research findings of Corey Herman in the Rio Grande de Chonie. All of these areas will benefit immensely from the extensive LiDAR research that we are planning in the Earth Archive effort. And we will conclude with some closing commentary and discussion by Juan Jose Ortiz, representing the Universidad Técnica de Manabí. Okay, that's pretty much it for the introduction. And with that, I will close this out and turn it over to the rest of the participants. Thank you.
Greetings. I am Francisco Valdez, archaeologist at IRD, the French Institute of Research for Development. We've been working in Ecuador since 2001 in a joint archaeological project with the Instituto Nacional de Patrimonio Cultural on the province of Zamora Chinchipe, where we discovered an ancient pre-Columbian culture known as the Mayo Chinchipe Marañón. The Zamora Chinchipe province is situated on the upper Amazon, on the frontier zone between Ecuador and Peru. It is there that the Mayo Chinchipe Marañón hydrological system originates in the eastern flanks of the Andes. The newly found pre-Columbian culture occupies the entire Mayo Chinchipe Marañón basin, with altitudes ranging from 1,600 to 400 meters above sea level. The upper Amazon is composed of varied ecological niches, where signs of ancient human occupation are found in the transformation of the original forest. Here scattered gardens have been present for thousands of years. There is no part of the jungle that has not been modified by human activity. Amazonia is truly a cultural landscape. Traces of human occupation can also be found on ceramic sherd deposits, or with polished stone tools. The most common sherds belong to the corrugated pottery tradition, associated with the Bracamoro or the Yaguarzongo tribes that inhabited the region since the 7th century AD to the present. The complexity of human settlements in the upper Amazon has not been thoroughly studied. Simplistic assumptions about small villages and scattered homesteads have been traditionally characterized by the tropical forest population models. Fortunately, new information that begs future research is slowly changing our perception of the way human beings adapted to an apparently limited environment and profited from the various resources and interactions with other regions in order to develop complex societies. The ongoing survey of the province has resulted in more than 400 archaeological sites from different time periods. The sites are located in the varied topographical settings that make up the different river systems of Zamora Chinchipe. Undoubtedly, the most important site yet found is the Santana La Florida site, located in the headwaters of the Mayo Chinchipe River, close to a town called Palanda. It is there that the most significant evidence of the Mayo Chinchipe culture has been studied. The site is located at the bottom of a river valley over a small fluvial terrace that is partly limited by a horseshoe-shaped meander of the river. The general layout is reminiscent of other early Andean ceremonial centers. A central sunken plaza, 40 meters in diameter, is oriented in an east-west direction, marked by two platform mounds situated at the extremes of the axis. Smaller circular structures surround the area covered by the plaza, with probable domestic maidens forming outside the perimeter of the public space. Monumental stone and earth architecture characterizes the public areas of the site. The two mound platforms are solid constructions that grew in size and shape over the years. The western platform was built over the declining curves of the mountain flank. A ramp and 5 stairs surge from the sunken plaza to reach it. The eastern platform is iconic of the architecture of the Mayo Chinchipe culture. Concentrical stone retaining walls form a spiral to hold in place the earth and the stone fill. In the body of the mound, several tombs and offerings were placed to sacralize the structure. The walls that converge at its vortex form a ceremonial hearth. At its base, a cache with greenstone medallions and turquoise bead strings was found, protected by an upside-down polished bowl. The most important funerary feature was a shaft tomb. Its entrance appeared close to the ceremonial hearth. The stone-lined shaft led to a funerary chamber at 2 meters in depth. The chamber contained the burial of at least 2 individuals that appeared on the eastern side. The paraphernalia included ceramic vessels, polished stone bowls, strombos seashells, and greased stone corporal adornments. These were mostly carved turquoise nodules, pearls, and malachite plaquettes. The importance of the individuals buried here is marked by the presence of seashells. These come from the Pacific coast and clearly show the interaction between the coast, the highlands, and the upper Amazon. Another interesting feature are the greenstones, which are exotic to the place. Turquoise, malachite, and other Amazonite types are not particularly known from the area. These interactions are not merely trade features. It is important to note that the presence of certain types of seashells is a characteristic of the Andean civilization cosmology. One of the ceramic vessels found in the tomb is particularly tale-telling, as it denotes the ideological sphere that probably motivated these interactions. The Janus stirrup spout bottle, included as an offering, shows the two faces of an individual emerging from a spondylus bivalve. The feature on one side seems calm and friendly, while the other one shows a more strict or serious character. But more important than the stern attitude is the feline mouth that the individual shows, suggesting the transformation of a human into a jaguar. The feline mouth trait is typical of the iconography from the coastal Valdivia culture, coeval with Mayo Chinchipe. The presence of the strombus and spondylus seashells clearly shows the ideological strength that this early Amazon society shared with its Andean counterparts. The polished stone bowls and mortars are also indicative of the sphere of interactions. The iconography carved on the exterior parts of the bowls show themes characteristic of shamanic transformation, as well as icons shared with other coeval Andean cultures, such as the case of the snake and the raptorial birds depicted in textiles from the Peruvian coastal site of La Galgada. Another interesting feature is the fruit depicted on a stone mortar. A cacao pod was naturalistically sculpted and represents the importance that this fruit had in the Upper Amazon society, not only as an energetic food staple, but also as an interregional trade commodity. Recent analysis and studies carried out by paleobotanists and geneticists in the site have shown that cacao was consumed in Santana La Florida 5,300 years ago. This is the oldest archaeological evidence for the social use of cacao in the world. It is also a strong argument for the Amazonian origin and domestication of the cacao thesis. 32 radiocarbon assays have given the chronological depth to the Mayo-Chinchipe Marañón culture. These range from 5,400 to 2,300 before the present, or 3,400 to 300 before the Common Era. Two ceramic faces have been identified, the Palanda and the Tacana. Current research has shown the presence of several Mayo-Chinchipe Marañón sites on both sides of the geopolitical border between Ecuador and Peru. In Ecuador, Santana La Florida is the most important site. In Peru, Monte Grande in Jaén is its counterpart. In these sites we can find the spiral stone architecture, the Pacific seashells, as well as the polished stone bowls and mortars with iconic models reminiscent of the Amazonian cultures. The use of light or imagery could greatly help detect new sites in the Mayo-Chinchipe basin.
When the Spanish set out to venture into the conquest of the mythical city of El Dorado in the eastern Andes, they did not imagine their encounter with a different world. In the midst of the dense vegetation, they did not find roads or land roads, nor did they find any city or anything that resembled the Andean village and their people. The rivers were their main routes through the jungle. The early chroniclers narrate their forays into this inhospitable territory, repeatedly highlighting their sorrows and misadventures in a land that they declare as the true image of hell. This first encounter of the Spaniards with the Amazon rainforest set a harmful precedent that, over time, was feeding and popularizing a distorted image of a hostile environment inhabited by savage populations. But the Amazon is far from being an homogeneous landscape from a biological, geographical, or cultural perspective. Nowadays, the tropical forest appears as a region with a clear anthropic footprint. The management of tropical forest resources, in some cases, led to landscape modifications that include the construction of a wide variety of earthworks associated with high organized settlements. Archaeology has documented evidence of extensive landscape transformation in the form of agricultural fields, drainage channels, roads, and earthen mounds, which appear distributed through larger areas such as the Llanos de Mojos, the Upper Xingu, the Venezuelan plains, the coast of Belize, or in the Marajo Island in the mouth of the Amazon River. In the light of the new evidence, urban planning concepts have begun to be considered and evaluated in the region. The recent use of aerial LiDAR technology in archaeological exploration has become crucial for a better understanding of ancient settlements pattern and the scale of anthropic transformation of Amazonian landscapes. In this context, the archaeological information available for the Upano River Valley region in the upper Ecuadorian Amazon presents a promising avenue for discussion on the emergence of complex political structures and the development of ancient forms of urbanism. The evidence of thousands of monumental earthworks and various nuclear settlements suggests that the valley was extensively modified between 400 BC and 400 AD. The Ecuadorian Upper Amazon is characterized by great geographical and ecological diversity. The central part of the region features an irregular geography composed of subtropical valleys located about 1,000 meters above sea level, and bordered to the west by the Cordillera Real Andina and to the east by the Transcutucu Mountains. The Upano River flows through the air of the valley in a north-south direction through a canyon that divides the territory in two sections. These conditions create ecological effects that allow for enormous biodiversity in a dense tropical rainforest landscape. The combination of this rich environment and its strategic location between the Amazonian lowlands and the high interandean valleys led to the flourishing of pre-Columbian societies with diverse forms of political organization. In the late 70s, Pedro Porras Garces reported that existence of hundreds of monumental earthworks with noteworthy level of spatial planning. Porras focused a good part of his time on creating a complete map of the Huapula site. This work included a pioneering way of aerial photographic record by overflying of the site with a small plane. Porras Garces argued that Huapula was the most prominent political and religious center in the region. This characterization of the site was based on the dimensions of the central group of platforms and especially its complex spatial distribution, in which Porras believed to distinguish a geoglyph composition representing the copulation between a human figure and jaguar. However, Salazar and Rostains has rejected these interpretations based on the information of improved maps of the Wapula site. The introduction of earthworks seems to correspond a late phenomenon of the extension of the Upano populations in the valley. The construction of monumental works is also associated with changes in ceramic production, particularly the manufacture of bowls and large jars that were probably associated with the consumption of fermented beverages. Polybotanical studies from the Wapula site indicates the consumption of maize and beans. The diet was complemented by the consumption of manioc and sweet potato, based on the analysis of starch samples obtained from ceramic fragments. Uh, Pagan Jimenez and Rostain proposed the maize may have been consumed in the form of chicha, a fermented beverage that has long been a staple of Andean and Amazonian feasts. The fact that the ancient inhabitants of Yupano ate maize and beans suggests that they probably prepared agricultural lands using drainage systems that would have reduced water retention in areas with nutrient-rich soils. Recently, some drainage systems associated with potential farming areas have been visually identified through the use of LiDAR images. Much of the interpretation of ancient settlements pattern in the Upano Valley has been based on non-systematic surveys of earthen mound areas made accessible by cleared forests. As a result, most of the archaeological sites identified during pedestrian survey were located on the edges of the Upano River Canyon. These sites are only a small sample of the extent of earthworks in the region. In 2015, the Instituto Nacional de Patrimonio Cultural del Ecuador collected LiDAR information for the northern Upano River basin in an area of approximately 300 square kilometers. The results reveal a dramatically modified landscape in the vicinity of the Upano River. However, the findings also demonstrate the ancient earthworks extending well beyond the Upano proper and include both secondary river and interfluvial zones, artificial mounds, road trenches, and plazas, an area probably related to agricultural activities, add up to more than 8,000 instances of monumental architecture scattered through the survey area. LiDAR images expose a complex and highly integrated landscape. The distribution of earthen mounds shows several clusters that indicates the presence of large nucleate settlements and what appear to have been hinterlands. This large-scale pattern reflects a change in the settlement model of the Upano groups in the region. Indeed, the presence of several nucleate villages refutes the thesis that Wapula was the only large center in the region and lead us to reorient previous interpretations about the socio-political organization of Upano people. Perhaps one of the most relevant findings of the LiDAR exploration comes from the Kunguin sites, which until recently was hidden under the canopy of the tropical rainforest. This settlement has around 1,100 structures over an area approximately 6 square kilometers. It is the largest known settlement in the valley. Kinguins is more than double size of Wapula, which featured at least 474 structures distributed over an area of 2.7 square kilometers. The level of detail provided by the digital elevation models highlights the complex composition of the villages. The major settlements present pattern of internal spatial organization that is suggestive of planned urban landscapes. Although the concept of urban is largely absent from historical and ethnographic depictions of the Amazon settlements, archaeological research from recent decades has begun to reassess how this term can be understood in the Amazon. At this point, it's worth noting that the emergence of urban planning has proven to be a heterogeneous phenomenon in response to a wide diversity of social and environmental factors. The design of the plan of settlements suggests that the constructing earthworks and organizing spaces were coordinated activities. In fact, new evidence has brought to light a recurrent pattern in the composition of the plan of settlements. The construction of the mounds, roads, canals was intended to demarcate plazas. Indeed, almost all of the earthen mounds registered in the valley are grouped around rectangular plazas. Most of the plaza mound groups are small and were likely occupied by close family and oriented around daily activities. However, in the case of large settlement, it is possible to distinguish the presence of large plazas that were probably used for communal activities. This feature, which is observed mainly in large villages, establish a notable difference between areas that could be interpreted as public and residential spaces. Mound construction and other earthworks substantially transformed the local environment, creating a complex socio-political space. The latest information provided by LiDAR images suggests that landscape transformation that is similar to an urbanization process characterized by large nucleate settlements such as Wapula and Quinquins, and an intricate spatial planning. The particular design of plazas and roads as the spaces that enable the reproduction of and strengthening of community ties appears to follow a common pattern of construction. The configuration of the settlements reflects a coordination in the selection and organization of spaces, as well as the standardized pattern of sets of rectangular mounds enclosing large plazas or quadrangular courtyards. A complex network of roads complement the ancient urban layout in the major settlements, while avenues from access that organize the connected the main plazas with minor groups of mounds in the villages. At the regional level, various sections of the roads connected sites and settlements, shaping an integrated landscape. The Upano Valley presents evidence of socio-political complexity with very particular characteristics that have not been observed in other areas in the Upper Amazon. The development of monumental infrastructure with complex urban planning during the Upano occupation substantively transformed the valley. Recent LiDAR data has revealed the presence of several nucleate settlements, the composition and organization of the spaces around small squares and large plazas, and the intricate networks of roads and drainage systems suggest carefully settlement planning as part of an urban design. However, LiDAR information shows a particular set of data and does not provide a chronological image. Therefore, it should be used carefully. It is clear that more archaeological research is needed to establish the different levels of social, political, and economic relationship of the Upano occupation. Modern technologies offer great potential for understanding this ancient landscape better and for guiding future investigations. Extensive sustained excavations and artifact analysis are necessary if we are to better understand the nature of the societies responsible for these monumental constructions and the socio-political changes that occur over the time. Thank you very much.
Hello, thank you very much to James Zeidler and the Earth Archive Project for inviting me to this conference. The long-term interactions between the Andean and the Amazonian regions have played a major role in the historical dynamics of South America prehistory. As an intermediate zone between these two principal culture areas, the Upper Amazon is one of the keys to untangling the relationship between these macro-regions. A case in point is the Cuyes Valley, a conduct between the Andes and the Amazon located in southeastern Ecuador. In the late 1970s, monumental structures, presumably pre-Columbian, discovered in this area raised the question of who the pre-Hispanic inhabitants of this valley were, Andean or Amazonian peoples. In this talk, I will present the hypotheses and perspectives brought forward by my PhD investigation on this issue. I will also touch on the potential of airborne LiDAR scanning research in this area. Previous studies conducted in the Cuyes variously hypothesized that its archaeological structures were Canaries, Inca, and/or Ain Shisham. The Canaries are an ethno-linguistic group organized into small-scale chiefdoms who inhabited the highlands of southern Ecuador. They were impacted by the Inca massive program of imperial expansion. As for the Ain Shisham, they were semi-itinerant farmers who reportedly came from the eastern Amazon and migrated into the region located between the Pastaza and the Chinchipe rivers. The architectural features identified in the Cuyes Valley were not clearly associated with any of these ethnic groups, nor was it known what kind of contact or relations, if any, may have existed among them. On the other hand, the Cuyes archaeological ceramics are typically plain, which inhibits the ability to analyze their cultural affiliation in terms of stylistic attributes. This is why I chose to study them from the perspective of the technological approach and the concept of chaîne opératoire. Ethnographic observation has demonstrated that due to learning mechanisms, chaîne opératoire end up constituting traditions among communities of practice and are therefore good markers of social boundaries, especially with respect to fashioning techniques, which are particularly resistant to change as opposed to the sole stylistic criteria. Reconsidering the archaeology of the Cuyes Valley first required a precise recording of extant archaeological sites. The 17 sites identified consequently are distributed among 5 distinct sectors. 4 hypothetical functions are suggested for these sites: residential, agricultural, defensive, and ceremonial. The first sector includes 3 sites with stone architecture: Espiritu Playa, a medium-sized rectangular building contiguous to a small one; La Cruz, a small circular structure located on the top of a low hill; and a cluster of 145 terraces with retaining walls. In the second sector, 3 sites were identified: Santa Rosa, a small schist stone building divided into 2 rooms with a trench at the rear; Sitio Playa, a compound of 4 trapezoidal earth and stone platforms connected by cobblestone paved paths; and a cluster of 172 terraces. In the third sector, there are 2 sites located on hilltops: Trincheras, the second biggest site in the valley, a construction with 2 levels of stone walls protected by 2 trenches; and Santo Pamba, a small compound made of 2 concentric stone walls without trenches. 2 clusters of 148 terraces were registered here as well. The fourth sector is located in the lower part of the valley, closer to the Amazonian lowlands. It has 3 sites, the first of which is El Cadi, a 10-hectare stone complex composed of 3 main buildings and a set of 24 walls. El Cadi is surrounded by 2 sites with trenches: La Florida, which comprises 4 concentric levels of earth and cobblestones, and Rio Bravo, a little semicircular cobblestone structure. Finally, the fifth sector, a complex of 29 terraces, 2 structures with levels of schist stone walls protected by trenches, Buenos Aires and Nueva Saruma I, and a small earth mound surrounded by a trench, Nueva Saruma II. The survey and excavation strategy implemented in these sites allowed to collect charcoal samples which radiocarbon dating revealed that the late occupation of the valley spans from the 12th to the 17th century AD, and from the 13th to the 17th century as well in the lower part. In order to identify chaîne opératoire out of the Cuyes ceramic sample, I first classified the sherds in technical groups on the basis of macroscopic and microscopic manufacturing marks visible on their surface. These marks can be related to specific technical operations thanks to experimental and/or ethnographic reference data. I built my own reference data through an ethnographic investigation conducted among potters from the Andes and the Amazonian lowlands surrounding the Cuyes. Moreover, a comparative sample of Cañari, Inca, and Ayan Shisham pottery coming from museum collections was also examined so as to determine the possible association of these cultures to the ceramics from the Cuyes. Continuing with the Cuyes ceramic sample, it was also submitted to a petrographic classification. Finally, the corresponding shapes and rare decorations of the sample were described as well. As a result, two different traditions were identified in the archaeological sample from the Cuyes. The first is represented by the modeling and beating techniques used on a clay mainly characterized by volcanic components, and the second by the coiling technique, which clay basically comprises metamorphic components. The ceramics belonging to the modeling beading tradition has been found in the Upper Cuyes. The clay used to manufacture it is local. The modeling beating combination has also been identified in the Cañari vessels of the museum collections examined. The contextual elements, as well as the regional data, seem to support the hypothesis according to which the Upper Cuyes was inhabited by Cañaris. The coiling tradition is essentially present in the Lower Cuyes. The clay used to manufacture it comes from nearby as well. This technique coincides with the one identified on the Ayan Shisham objects from the museum collections examined, which would indicate that the Lower Cuyes could have belonged to the territory of Ayan Shisham itinerant farmers. Looking at the big picture, this study reveals the movement of an Ayan Shisham population into the Cuyes Valley, which was already inhabited by Cañaris in the 13th century AD. Regarding the contacts between these groups, the presence of defensive architecture in the Cuyes may thus indicate, if not conflicts, at least tensions between Cañaris and Ayan Shisham. On the other hand, the architectural characteristics and the exogenous objects found in the El Cadi site stands for its use as a trade center between the Andes and the Amazon. Though Cañaris and Ayan Shisham undoubtedly interacted, there appears to have been no exchange or borrowing of production techniques, at least as far as pottery was concerned. The maintenance of distinctive cultural features between different social groups living in close proximity is frequently noted in the anthropological literature. Most of the Cuyes Valley is covered by rather dense forests. The sites I presented you are known nowadays because they are located in areas inhabited by a small community of colons. Contrarily to pre-Columbian times, this inhabited surface is very limited today, which suggests that many more archaeological sites remain uncovered. These sites would undoubtedly bring forward key information on two crucial episodes of the late pre-Columbian history of the region. That is, the arrival of the Ayan Shisham to the eastern Andean slopes and the Inca presence in this area, a topic still underexplored. Moreover, I did not consider it in my research, but it seems like two sites of the Cuyes Valley are related to the formative period, a topic which, at least in this particular area, is widely unknown as well. So the use of airborne LiDAR scanning research in this area, which access is still very difficult, would definitely be a great step forward. Additionally, due to its mining resources, the Cuyes Valley, unfortunately, is threatened by extracting companies. So far, the inhabitants have managed to stop them by promoting local natural and archaeological heritage. The identification of more archaeological sites would help to reinforce their defense and contribute to protect the Cuyes from irreversible destruction. Thank you for your attention.
Hello, everyone. I am Ferran Cabrero, and I am going to talk about archaeology and geographical information system in the Pastaza Basin in Western Amazonia. Well, the objective is to summarize the works that have been done in the area in the last years. geographical information system in the Pastaza Basin applied to archaeology has a short and unequal story with few but important advances. Two sites can be cited here. First, the so-called Tesulai. The Tesulai, which is famous in the area, refer to an old state and tea company that has become an indigenous people reoccupied territory a few years ago. Here we have an image, an orthophoto of Tesulai. This image is thanks to the Cultural Heritage National Institute, INPC, a photo from 2016. And you can see here the image made by through thanks to leader data that it can be you can see like small elevations which here locally are called olas. Human-made elevations. So this is like a big city, a mound village, a big city, well known in the area, but with few studies. Since the official report by Murillo in 2006, 15 years ago, when she reported 44 colas or small pyramids with important conclusions and recommendations that shows, in fact, two zones, a recognition area and a larger desired protected area. Few advances can be shown from this GIS approach. 4 years later, this report by Murillo, there was an important work by Vasquez and Delgado in 2016. Included more maps and 6 neighborhoods were recognized in the area. In addition to a proposal on population density and a date of around 2,500 before present BP. Here you have the protection area proposal for the archaeological complex of Tesulai. And you see here a distance on your right hand, a distance to the new site of Rio Chico that we discovered recently. It's nearby this new site. So this new site was not recorded by any leader system, but this is a new discovery working with the local people. Here you see yellow spots and blue spots in Tesulai. This difference is between the first tolas or small elevations that were discovered at first and the tolas that were discovered by the leader system. We are talking about more than 150 tolas. But let's focus on Rio Chico, the newest site on the area. It is in an area of andosol soils in gray, good for agriculture. Here we have drawn images from 2019 of the Rio Chico site. This was thanks to a collaboration with Alabama University, with Terry Wayne Miller, who died 2 years ago, and Tanya and Pepe Ortiz Aguilú. Thanks to their collaboration, we have these images, and here we have another map with the 8 new tolas discovered are shown. These tolas or small elevations. Well, here there is a discussion. There is a different point of views. Around 10 years ago, there was this project by Stefan Rostein as well in the area, and Stefan was arguing that these small elevations were in fact hammocks. This kind of geological formations due to volcanic explosions, volcanic sediments coming from an avalanche spelled by big eruptions. In this case, by the ancient eruptions of Tungurahua volcano, which is not far. Well, I think this discussion between whether these small elevations are human-made or nature-made can be summarized finally that both of them, I mean, Rostein and Delgado and Vasquez, both researchers, or the 3 researchers are right. They are right, because sometimes we find hammocks, and other times we find tolas. Tolas are smaller than hammocks. So I think that as they work in different areas, they see different pictures of the situation. So here we have a photograph of Rio Chico Site with a lot of pottery. Rio Chico is the oldest site, the oldest known site of the area. We are talking about 2000 years before Christ. It's around 1000 older than Tesulai. And one of the interesting things of Rio Chico is pottery found, but pottery from the Andes. Well, this is we think that this is a proof of this long distance trade with the Andes, which are not so far, but there is a distance. In addition, we have an interesting results of paleo diet, and for the first time we have find chili pepper, sweet potato, salsa parrilla in the area. And then there is this new site, another new site, so a 3rd site in the area that we are working now, which is close to the others as well, with $7 or hammocks. We are doing research on that just right now. Here we have these 7 small elevations, and we will try in the near future to have more results. So this is what is being done in the zone, in Western Amazonia, Upper Amazon, this kind of rainy jungle between 900 meters and 400 meters, with very deep rivers like the Pastaza River, affluent to the Marañón, and Bobonasa, as well as the Curaray River, which is an affluent to the Napo River. Very meandering river, a very interesting river and big river, the Curaray as well. This was a zone occupied since the late formative and through the what is called in Castilian desarrollo regional, no? Regional development between 500 BC and 500 after the life of Christ. Well, this is the summary of the research in this area. So you can see, for me, there is these two big villages, one up to the Pastaza River or up to the left bank of the river, Tezulay, Rio Chico, the other side that we are working, and the other big mountainside, big city, ancient city, below the Pastaza, below the right bank, which is the Sangayupano. So around late formative development, regional development period, we have, I think, this interaction between the two big cities and long distance trade with the Andes.
Hello, everybody. Thank you for the opportunity of participation to the Earth Archive Congress. I am going to present the LiDAR application in the Cerros Hojas Jaboncillo, Manabí, Ecuador, new perspectives in research, conservation, and management. The cerros, or hills, Hojas Jaboncillo, are located in the central coast of Ecuador, in the province of Manabí. It is a mountain range that rises up to 650 meters above sea level, surrounded by the city of Puerto Viejo, Montecristi, and Manta. Known worldwide since the American archaeologist Marshall Saville investigated them at the beginning of the 20th century. Since 2009, the government of Ecuador ordered the research, conservation, and opening to the public of this site. For about 10 years, this place has been investigated, centering the research in the Manteño culture that occupied these hills from 800 to 1500 AD. However, these hills present a dense vegetation layer with two types of forests, the tropical dry forest and the humid forest. This has always represented an obstacle to understanding the magnitude of this archaeological site. In 2016, the Military Geographical Institute of Ecuador carried out a LiDAR flight over 14,300 hectares over these hills. This flight obtained a digital terrain model of high resolution, allowing us to visualize all of these hills with a vision similar to an X-ray, avoiding the forest layer. In this sense, what was previously perceived only as a dense tropical forest can now be visualized as an archaeological macro settlement, a before and an after in the history of this emblematic site of Ecuador. Before our eyes, then appears a complex system of terraces, platforms, hydraulic systems with channels and reservoirs on a large scale, with structures located both on the slopes and on the mountain tops. As we can see in the following slides, the orthophoto shows us a totally natural space. Instead, the digital terrain model with the LiDAR shows us the monumentality of the site, and in the LiDAR 3D footage, we can also understand the difficulty of the terrain and the transformation capacity that the ancient settlers had to convert these hills into habitable, productive, and even ceremonial spaces. As we can see in the following slides, the orthophoto shows us a totally natural space. Instead, the digital terrain model with the LiDAR shows us the monumentality of the site, and in the LiDAR 3D footage, we can also understand the difficulty of the terrain and the transformation capacity that the ancient settler had to convert these hills into habitable, productive, and even ceremonial spaces. In the case of the top of this mountain, currently where there are telecommunication antennas, a series of modifications were identified. Later, during field service, we confirm them as archaeological structures, platforms, and reservoirs, with the presence of stone seats and other archaeological objects in surface. In the same way, a series of field surveys were carried out since 2018 to verify if the geoforms initially detected through LiDAR corresponded to archaeological structures. It is interesting to note, once the route taken was recorded, the landscape differences between the orthophoto and the LiDAR. We can see terraces everywhere. These hills have more than 50 modified peaks or hilltops. In this image, it can be seen that one of these hilltops presents a complex of organized structures, aligned how long the top of the mountain is, oriented from north to south, demonstrating a planning of the spaces. During field surveys, the presence of important archaeological ruins was confirmed. The retaining walls and foundation of the structures were detected on the surface, and their typology was also catalogued. The structures of the Manteño culture, known as corrales, correspond to buildings made with bareque walls, wooden posts and ceilings supported by the guadua cane and covered with plant palms such as cade or toquilla, built on imposing stone platforms. Here you can see an artistic reconstruction of what could be the area we surveyed. Work has also been done on various dissemination projects through virtual reconstructions. In this slide, you can see around 50% of the total of the Cerros de Hojas Jaboncillo. As we can see it's a dense modified territory through hundreds of terraces, channels, and structures, where the smallest available space was used for human occupation. It is considered that this place could host more than 10,000 inhabitants at its apogee. All the identifiable archaeological areas are currently being registered thanks to the support of the LiDAR tool, separating the agrarian spaces from the settlements. We can also understand the use of the landscape. A codified registration process was implemented thanks to the topographic map of Ecuador and by means of files for each archaeological area, indicating its coordinates, orthophoto, LiDAR DTM, and 3D, and the georeferences images in profile, in addition to the necessary control data for its systematic update. Actually, we have 210 archaeological areas that have been registered thanks to this system. The application of LiDAR also allows us to better protect these hills, which in addition to presenting an ancient human history, are still a biodiverse natural ecosystem with endangered species such as ocelots, deers, anteaters, and others. Around these hills, there are more than 10 stone quarries, which inexorably advanced before the urban development of neighboring cities. In 2010, 3,500 hectares were declared as cultural heritage of Ecuador, which are protected by a patrimonial polygon. I will restart the last one. Okay. Around these hills, there are more than 10 stone quarries, which inexorably advanced before the urban development of neighboring cities. In 2010, 3,500 hectares were declared as cultural heritage of Ecuador, which are protected by a patrimonial polygon. But since 2018, it has been discovered that the archaeological complex has more than 7,000 hectares of archaeological elements, and that the current polygon must be expanded and zoned as we proposed since the year 2020. Likewise, this archaeological complex suffers from other risks, such as deforestation, the advance of the agricultural and urban frontier, Volcanism or looting, problems that must also be mitigated with the support of local governments and society in general. As we can see in this image, on the right, the city of Puerto Viejo in continuous growth, and on the left, the Cerros de Hojas Jaboncillo archaeological complex. There are two worlds that collide and must coexist. In this sense, the LiDAR tool has generated an awakening about the monumentality of this site, thus allowing everyone to finally see the city of the hills. in all its extension and gather the necessary efforts for its investigation, protection, and management. Thank you very much.
Good morning, good afternoon, good night for the people who's listening to this video. I am Florencio Delgado, and I am gonna speak to you about a project that we have been working for the last 4 years in the northern province of Manabí. And the project is population dynamics on the Cuaque Valley and neighboring areas. And so today, I'm gonna discuss a little bit about the purpose of our project, the methods we have been using, as well as some of the results I'm gonna share with you that allow us to engage into a small discussion on the results that are preliminary, of course, and from where we can draw some conclusions. The purpose of our project is to study the population dynamics in a hardest environment like the one in northern Manabí. And the questions basically is, can a society be resilient as a closed system, which means that's by itself certain communities can recover from problems or that the environment poses on them, or does it really needs some other sort of responses? And basically the question is, how can the pre-Columbian society have attained such level of complexity on such dynamic environmental conditions? As you can see here, this is recent pictures, and the purpose of this is to show you that the area has been really dynamic in terms of how has been affected by natural conditions. One is the volcanism. The first picture you can see is one of the volcano near Quito or over Quito. And what it does is, although the area we're working is in the coast, these plinian kind of eruptions really gets ashes, a column of ashes like kilometers, and so those are pushed by the wind and gets into the coastal regions, and in some areas it can really develop into layers of 10 to half a meter of you can get a deposit of 20 to 50 centimeters of ash. And what we can see in the area is successful of events that really did cover the area with ash. And the El Nino phenomenon or event also that occurs in a periodicity of at least 5 to 10 years, when the rains are really extreme and the area are flooded. And to that you can add things like the fact that the area is near this very intensive site where the Nazca the Nazca plate has really, it moves around, and so you have a very tectonic area where this is the pictures you see here are the results of the the 2016 earthquake that really was, I think it was 9.4 on the Richter scale, and really destroyed some of the areas in northern Manabí. And it gives you an idea of how this area has been affected through these things. And so, even in this, given that situation, the whole idea is how we can understand the responses that local communities had in pre-Columbian times. And to do that, we basically conducted a regional survey where we did some surface collections of surface surveys, using various service methods. Some had to do with being very systematic, and some others were just based on where we can get. Really, in some areas there is no roads, and so we did go into as far as we could. And the whole purpose, or the whole idea, is to get a reconstruction of regional chronology and also the reconstruction of environmental conditions in order to see how population dynamics have been working in the area. The results, briefly, if you see this map, the areas, the dotted areas are areas where we found cultural material, either as in a way of mounds, or as in surface collection, or in the river cuts, while the early sites could only be located through river cuts in the lower valleys. We did register most of the sites that are through surface collection or shovel testing. There are some very deep sites that we would never be able to see if we didn't go through the river cuts. And in the northern area, it's a mangrove area in the northern part, and there most of the sites really are shell middens into the mangrove, so those are easily located. And so we found more than 100 sites. 50 or more belong to the regional development period. And what we have found is, a dynamic movement from increased population to decrease in population that I'm going to show you. We have to say that at this point we have not defined really well the regional chronology, and so we are still talking about period in terms of periods, which covers sometimes more than 1,000, sometimes more than 2,000 years. In the northern Manabí, basically, we found the first occupation belongs to the early formative. The early formative in Ecuador ranges from 3,500 to 1200 BC. And what it occurred at the area we're working is the last of the early formative. Early formative is also represented by the Valdivia culture, which is at least 8 phases that represents cultural change. And the late Valdivias are present in the area. And while in the Hama Valley, the near Hama Valley where Jim Sally works, he identified collapse of the Valdivia during one of the volcanic eruptions. around 1600. In the area we're working, in the near valley, the late Valdivia occupation goes until 1200 and sometimes less. And what it has is that this occupation has many similarities to what Jimmy and other people are finding in the Hama Valley, especially around San Isidro region, and but incorporates other features such as that are found in Cotocollao, Face and Quito, and some of what we can call it Machalilla in the south. Incorporates, as you see in this picture, all the effigies and stone tablets, and as we think is very related to the Cotocollao groups up in the upper areas. And as you can see, most of the sites are. There is some sites inland around the river valleys, and a group of them are also on the coast, on near the beach. So we're still working on the material, but we think here we are going to find these two types of sites, so the coastal ones and the ones inland. For the second big occupation, which is the late formative, we see a decreasing number of sites. That could be based on, the vagaries of sampling, or the fact that really the area was abandoned and later was refilled. And this is the picture of what is going on, and we still working on the chronology, but we see similarities with what James Haller and his group has been finding in the Hama Valley, which are this Tabuchila face pottery. Most of the sites in this period are close to the water courses, and there is there's one that's close to the coast, but within the river, or close to the river. And then the regional development and integration period, it covers 2,000 years. We have not yet been able to divide the Hamaquac and compound and smaller units. We are working with what James Haller has done in the Hama Valley in order to see if that scheme really fits on the Quaque and neighboring areas, but we still are working on this. What is really clear is that there is a very big increase in sites in the area, which of course is an increase, or at least represents an increase of local population. Well, and also the sites represent as dots, just for purpose of showing them. If we see, if we can, zoom up, you will find out that that the sites increase in size, and there are that we're seeing some sort of site ranking. Some are mounded and some are not. So this is, or evidence allows us to show that, there's been a long history in the area, as Haller also shown for the for the Hama Valley. And this can be the result of constant abandonment and repeopling. There is an increment during the Hamaquaque occupation, although we need to divide these 2,000 years in smaller units, which there changes. The area is composed by lowland, coast, and mangrove regions. We believe that perhaps during ashfall times, these communities moved to the mangrove area, where they can get away from this sort of ash accumulation. And so what we're thinking that that during the El Nino, it seems that they move to the higher areas. And well, you know, in terms of the telluric movements, that's I don't think moving will do anything to it. But we think that maybe what you have in this area is these populations that are moving, facing this kind of natural situations. And I think we are trying to sample and get data that will support our claim. Our confidence on our data, however, is limited by the fact that we have not been able to survey the mountain range covered by heavy vegetation, and that's what I think the use of technology such as LiDAR will help us to really have a complete picture of what really goes on in the area. Finally,
hello. This paper is entitled Pre-Hispanic Earthworks in the Hama River Valley and Rio Grande de Chonie area, and is co-authored by myself and my colleague Corey Herman from Yale University. Our aim here is to examine current knowledge of ancient earthworks in these two areas and consider how future LiDAR scanning can help us better understand them and their nature and distribution throughout the region. Here's a map of Ecuador showing our location. The Hama River Valley is located in the upper northwest of that rectangular area. The Rio Grande de Chonie is just to the southeast end. We move to a cultural chronology of coastal Ecuador, showing a highlighted area in the center labeled Northern Manabí, which is where both of our study areas are, and shows the ceramic sequence. I want to draw your attention to the right column there in the highlighted area. That is the Hama Valley ceramic sequence, starting with terminal Valdivia Piquigua phase, going up to late formative Tabuchila phase, and then a series of Muchique ceramic phases, 1, 2, 3, 4, and 5, with interspersed, you'll see there in red, with a series of volcanic deposits, which have had variable impact over the course of the sequence, sometimes causing complete valley abandonment, other times phase changes, but nothing serious in the way of abandonments. We're primarily concerned with these Muchique phases, 1, 2, 3, and 4, although it's important to mention some earthworks, some mound structures were initially constructed in the formative period, Piquigua and Tabuchila phases. Earthworks in the form of large ceremonial platform mounds have been known for some time based on ceramic effigy bottles that have shown up in museums and private collections. Here we have two excellent examples of Hamakuake mound effigy bottles, and you can see that they are in the form of stepped pyramids or stepped platform mounds of different, radically different styles, but these are both from what I would call Muchique phases 2 and 3. And it's important to note that they are functioning bottles. And on the left, we have a double spout and bridge bottle. And on the right side, a single large spout at the top of the pyramidal mound, both containing elite effigies of elite figures sitting inside the ritual structures. Large platform mounds are also known based on their presence in modern towns and modern surfaces of some of the larger towns throughout the Hama Valley. Here we see a topographic map of the San Isidro site in the center of the valley, thought to be one of the primary chiefly mound centers of the valley. And you can see it's right smack in the middle of the town itself. Here on the left, we have a picture of it. It's basically 88,000 cubic meters in size, measuring about 100 meters by 100 meters and 17 meters in height. And you can see, although it's rounded up at the top through modern living and modern use and erosion, it did initially have a square base to it. Based on some of these finds and some of the early work that I did in the Hama Valley during the 80s, we decided to embark on a much larger survey to locate archaeological sites and try and study in more detail the presence of these, the nature and presence of these mound constructions and other earthworks over a valley-wide landscape. So we defined a archaeological study area about 785 square kilometers in size, here bordered in black, which comprises a large central portion of the lower Hama Valley from its 1,600 square kilometer drainage area. This was a project that I co-directed with Dr. Deborah Pearsall, a well-known archaeobotanist, as we went after site locations and settlement dynamics, and she was focusing on agricultural production in these archaeological sites. We had a fairly complex sampling routine. I won't go into detail here, but we concentrated on 100% coverage of beach areas, alluvial areas, and about 130 sample quadrats, random quadrats in the upland areas. And as a result of all this work, we were able to record 232 archaeological sites, which contained 106 mounds at 58 of those sites. So about 25% of those sites, total sites, contained 106 mound structures of varying size, which we'll see in a minute. And we also located a different kind of earthwork, 12 paired berms, or what they call locally cordones. And we'll see what these look like in a minute. These were found at 9 sites. This is a map showing the results of that survey. You can see the archaeological sites in red here, and you'll notice that in green, we've sort of placed the mounds, not to scale, of course, but just give you an idea of the location and dispersion of these mounds. You'll see that neither the sites nor the mounds are randomly distributed. They're tightly clustered in rich pockets of alluvium in the lower and upper, middle and upper valley of the site, of the study area. And the largest mounds are typically located in the center of mound clusters. So other smaller mounds of varying size are clustered around those large mounds. A good example is San Isidro and also Santa Rosa in the lower valley. We've divided these into specific size tiers, and if you look at the column on the right, total mounds by size, you can see a rudimentary hierarchy of these size tiers. Only 6 of the largest mounds occur, 4 in the lower valley, and 3 of those are from a late period, and 2 in the upper valley, middle and upper valley, and then you get more of the size tier 2 mounds, and a proliferation of the size tier 3 mounds. This other earthwork type is kind of unique to this area. I don't know of it occurring anywhere else in Ecuador, but they're basically what we could call berms, or long, narrow slivers of mounds, not very high, usually 1 to 2 meters maximum. In some cases, mostly they're parallel in shape, but we do have examples of U-shaped forms of these things. And their purpose is unknown. We do have a radiocarbon date. We know they're from probably Muchique 4 at the very tail end of the sequence, about 800 AD to 1500 AD in the Spanish conquest. And again, you can see size tiers here. There's only one at the very largest, over 3,000 square meters in basal area. And then they range down to very small, down to less than 300. So one of the things we're trying to do with LiDAR scanning, or we hope to do with LiDAR scanning, is to sort of get a better handle on the nature of dispersion of these mound centers. We think there were 3 main, chiefly mound centers at Santa Rosa in the lower valley, San Isidro in the middle valley, and a site called Zapallo in the upper valley. possibly dominated through much of that sequence by San Isidro, but they could have been also autonomous at various times. And we think LiDAR scanning will help us get a much better handle on all of this by first finding more of these kinds of earthwork structures, which we know show up quite easily in LiDAR scanning at high resolution, but also to get a better handle on the geospatial distribution of all of these things over a regional area. Okay, I'll stop there and turn it over to Corey.
Thanks, Dr. Seidler. The second half of our talk will focus on the Rio Grande de Chonie, a river valley about 50 kilometers south-southeast of the Rio Hama. From the perspective of archaeology, this region is largely unstudied and has been considered a frontier of a sort, with only scattered looting and private collections to provide insight into past occupations. However, archaeologists like Kent Lightfoot and Antoinette Martinez remind us that frontiers are far from marginal places and often prove to be vibrant zones of exchange, where assertions of contrasting identity can be made. Additionally, as several investigators, including Dr. Seidler, have noted, this region has been identified as within range of numerous volcanic eruptions which occurred through the last several thousand years. The idiosyncrasies of each eruption's nature and timing, along with the varied geography of the Ecuadorian coast, mean that any given eruption was not experienced uniformly, even with equivalent distance from the caldera. With all of this in mind, investigations began in 2018 in the Rio Grande de Chonie and the ongoing pursuit of my doctoral thesis research at Yale University. This investigation maintains several intertwined lines of questioning. What contributions did the people of the Chonie region and the hilly coastal interior make to the history and development of South America before and during European settler colonialism? What priorities of life and society were revealed to those affected by stochastic volcanic eruptions, including and beyond the basic need to survive, and how are these events managed, remembered, and encountered by their descendants? And regarding LiDAR application in the current discussion, how can we interpret the palimpsest of anthropogenic investments made by nearly 4 millennia of occupation in the Rio Grande de Chonie, following principles established by historical ecology and informed by modern community priorities and practices? As of today's discussion, the Proyecto Arqueológico Rio Grande de Chonie has identified more than 40 archaeological sites in 2018 survey and conducted excavation and shovel tests at one of these sites, La Paja La Ñurusa, in 2019. Long-term, this project seeks to build and maintain capacity for local communities to pursue archaeological investigations themselves and invest in local tourism or other development as they see fit. With the remaining time available to me, I'd like to enumerate a few of the large-scale earthworks and anthropogenic investments which LiDAR scans of the Rio Grande de Chonie would recognize. Given the proximity to the Hama Valley and Dr. Seidler's foregoing discussion, some of these should be recognizable and comparable between regions. One of the more notable hypotheses that the project has floated is the potential for water control and retention. The southern Ecuadorian coast is known for its U-shaped albarradas, which retained water in times of scarcity. While these U-shaped features have not yet been recognized in the Rio Grande de Chonie, managing water was likely a high priority for communities in this transitional ecological zone. Large reservoir features at the base of the steep hills which frame the valley have been identified at several locations, which you can see at the top part of this slide. Associated with these are often series of raised berms oriented across the hillsides, perhaps allowing for extended usage of water and management of agricultural products which require varying amounts of moisture. Mirroring descriptions in Hama, there appear to be berms oriented downhill slopes identified in multiple areas. They're called cordones. These may be monumental investments made by later occupants of Uchique 4, as they seem to cut through earlier Churrera occupations and ceramic middens. As can be expected for most anywhere in South America, mounted earthworks known as tolas in Ecuador have also been recognized in survey in Chonie. Many of these obvious markers of past occupation have been recognized and even looted, but others remain intact, though variably affected by the return of the forest or subsequent clearance for modern orchards or pasture lands. Survey has mostly recognized rounded forms thus far, so circular or oval within Dr. Seidler's inventory, although these often appear in pairs or in daisy chains of up to 7 in a row. One peculiar tola shown here, while severely damaged by looting of the principal mound, displays a squared profile about 10 meters long at the base, with a roughly 10-meter ramp coming off of its southwest face and a 10 by 10 meter raised plaza space adjoined to the opposite northeast face. At this scale, LiDAR will certainly be able to distinguish between these ramped and rounded tola forms and will likely aid in delineating further types and scales of these landmarks. Closing out this very brief inventory, there's also numerous other plain spaces and plain terraces which have been identified. While some of these may be taking advantage of the prevailing geological conformation, Others appear at different strata and were not produced by modern development, at least within modern memory. In all, it's already becoming clear at this early stage of research that the Rio Grande de Chonie had its own distinct trajectory of social histories, volcanic exposure, settlement, and abandonment, distinct from that of the trajectory of Hama. As I close out this discussion, the wondrous ecological and social diversity present currently in the Rio Grande de Chonie has the equal potential to be enriched or damaged by the revelation of LiDAR. Work within the project in Chonie will thus foreground dialogue and questions that modern communities have of the data that LiDAR provides. Making sure these communities have the capability to ask and answer questions about their land and its past and present use through this data set will be itself a daunting but really exciting task. And I hope that future iterations of this Congress will be able to live up to that ideal of empowering the people of the world to utilize this vibrant resource in pursuit of past, present, and future alike. Thank you very much.
Hello, everybody. My name is Juan Jose Ortiz Aguilú. I'm an anthropologist, archaeologist at the University of Manabí in Ecuador. I thank the organizers of this Congress for the invitation, and we will be sharing with you some thoughts on the implications of LiDAR technology in archaeology in Ecuador and particularly in Manabí. I have listened to the excellent presentations of my colleagues from Ecuador on different issues of archaeological interest in different parts of Ecuador, especially in Amazonia, and some of them in Manabí, the province where I'm located. We'll start with some observations of the works that had been presented in Amazonia. Dr. Pazmiño's presentation touched on a very interesting research, brought up some very interesting points about LiDAR. The complexities that the work that Dr. Pazmiño has been doing are without question even more complicated by the very difficult terrain and environment that we all know Amazonia is. He brings to the table, however, some interesting observations about the fact that LiDAR will, of course, let you know where things are, but LiDAR will not tell you how old things are. LiDAR will not tell you the different relationships between settlements or buildings or spaces, etc. So chronology is something that we have to work at besides location. However, there's no question that the plethora of information obtained by LiDAR will definitely bring the quality of data to a next level. We see the same observations basically made by Dr. Valdez in his fantastic work of the Zamora Chinchipe region with the issue of the Mayo Chinchipe Marañón culture. These very, very fascinating sites with spiral architecture, which indeed is something that can be benefited quite a bit by proper mapping and regional mapping. It's clear that these are the kinds of things that where LiDAR can contribute. There's no question that the amount of work that he and his colleagues have done with traditional archaeology of the most excellent quality have achieved great heights in depth of interpretation. But we do know, and he suggests that, of course, LiDAR will help in this sense, especially again in this very difficult area of the Amazonian area. Dr. Catherine Lara in the Cuyes Valley has also mentioned the the need for the use of LiDAR for difficult places with difficult access. However, she mentioned something, an angle, a very interesting angle, and that is that the sites in the Cuyas Valley, according to her research, are in great danger from mining and from normal looting and so on that goes on in some of our areas. So the more sites are found in terms of that region, the easier it will be to make a case as to the need for protection of that patrimony. Ferran Cabrero brings also to light the whole issue of Rio Chico site, which is a very early site, and the detection of tolas or mounds that are associated to this site. It's a very interesting area that also presents a unique opportunity of collaborating with local communities and students from the local area that are associated to the University of Puyo, where Dr. Cabrero teaches. The detection of mound complexes, for example, is an issue that Jim Seidler has been touching upon together with Corey Herman, and the relationship between mound complexes and structures and different regions is something that, of course, we all hope that will be aided by LiDAR detection. This happens also in hilltops that are sometimes very difficult, which is another point that was brought home by Florencio Delgado in his Cuaque Valley research, where he posed a very interesting hypothesis of population shifting from one point to another according to or in reaction to environmental changes such as seismic action, activity, or Nino, or volcanic debris. And key environments like lowlands, coast, and the mangrove are very important in understanding these dynamics that Florencio postulates. And of course, again, LiDAR could help in this sense. Well, now I think I will bring to the table a specific example of LiDAR application, where we can see the changes that will be that are heralded by this technology. The province of Manabí in Ecuador is one of the richest archaeological regions in South America. Among the hundreds of registered sites and site clusters, none is more impressive than the hill complex of Jaboncillo. Referred to as Jaboncillo, it's really 6 peaks that run into each other in the province of Manabí. It was inhabited and settled over by the Manteño culture in between 800 to 1500 AD. These were the people that ruled the coast as the Spaniards landed on the coast in 1531. In 2011, Dr. Jorge Marcos assembled a team of archaeologists, of which I was part of, in order to study a 35 square kilometer complex. And not long after the data from these efforts assembled, we began to see that the complexity of the remains far outpaced what the original studies by Saville had done in the beginning of the 20th century. In order to account for the complexity and elaborate sets of archaeological data, Marcos proposed in 2011 that Jaboncillo was the political and cultural center of a Manteño proto-incipient state formation that existed in late Western Ecuadorian prehistory. With this as a guiding working hypothesis, it became clear that the study and eventual historical and social understanding of Jaboncillo would best benefit the area from a wide area approach. As an attempt to examine part of the existing LiDAR data of Jaboncillo complex, we have begun to focus on critical questions such as the number of terraces, their functional purposes, and surface water manipulation. On the screen, we can see the area of Jaboncillo and the LiDAR footprint. One of the most impressive initial evidence that was detected is the clear evidence of water drainage manipulation. As we can see in this graphic, we can see that water courses run in a direction that are specifically avoiding the terraces, which are the ones with the mango-colored areas. We believe that the wide area approach is much more revealing to understand the internal workings of regional impact of Manteño social formation during its last 300 years before their destruction by the Europeans. This illustration you have on screen shows you the density of terraces that has already been discussed by our colleague Juan Gijon in his magnificent presentation of the results of this LiDAR flight. We have extracted terrace construction from LiDAR data and created another digital database that has given us the result of an extraction count totaling a minimum of 25,805 constructed terraces. This is an account. It's not an estimate that we made using a protocol for the extraction and the detection of what appears to be man-made surfaces, in this case, terraces and structures. This is clearly way beyond anything we expected to find. So we believe that in cases such as this, the wide area approach is way more revealing to understand the internal workings and regional impact of the Manteño social formation during its last 300 years before the destruction by the Europeans. I would like to say that the LiDAR technology has much more far-reaching consequences than just helping us find more sites and structures in difficult terrain. In the first place, by being available, this kind of data stands to transform the nature of survey and exploration projects. This change will only be in the methodology to be employed, will not only be in that, but it will also be in the economic and logistical planning as well. Research objectives will definitely go beyond search and find to more question-specific goals. Indeed, questions of highly theoretical importance can be approached now in a much shorter time than by traditional methods. Questions about chiefdom networks, initial state formations, long-distance trade, relationships, and other connections between one region and another may be approached by the detection of infrastructure such as roads and trails. Finally, there is the issue of ethical access to this data. The ability to produce a map so exact that objects as small as 30 centimeters in dimension can be located and seen from the air brings to the table a very difficult dilemma. Can we actually publish and have available unfiltered access to this kind of data? Of course, on the other hand, we cannot and should not control in exclusivity the data that belongs to the history of communities that have allowed us into their land to study their past. Allowing unfiltered access, however, to precious data about the heritage that we are so intent on protecting will be at least a recipe for disaster. It is definitely an issue that will not go away and will have to be dealt with constantly and permanently. Thank you.